We're given a circle with center C, and it has this equation, and we're asked to find the coordinates of C and the radius of the circle. Now, the general equation for a circle is x minus a squared plus y minus b squared equals r squared. And the center is then AB, and the radius is r. And you can use Pythagoras' theorem to prove that if you plot it on a coordinate grid. So we need to try to get this equation up here in that form, and that's going to involve completing the square, because I've got an x squared and I've got a minus 8x, so that's going to be x minus 4 squared. Then I need to minus 16. So the red bit I've underlined is this red bit here. Then I can deal with the y. So I've got y minus 2y. It's going to be y minus 1 squared minus 1. And finally, I've then got the minus 3. And it equals 0. Just need to tidy this up. X minus 4 squared plus y minus 1 squared. If I add all these onto the other side, it's going to be 20. And that gives me a center of 4, 1, and radius is going to equal root 20. In part 2, we're asked to find the values of k for which the line y equals k is a tangent to the circle, giving our answers in simplified surd form. And whenever you get something like this, I think a really good idea is to get a sketch down of what is going on. I'm going to draw, let me draw my axes first. I was just trying to decide, should I draw my circle first? Now I know the center is 4, 1, so it's going to be like here. Now root, do I know that it goes through the axes? We can think about this. The radius is root 20, which is greater than 4. So it is going to go through this one on the left. It's not actually that essential, but I'll just try to draw it reasonably accurately. And then remember, we're talking about a tangent y equals k. So that is these parts here. This and also this. We can use our sketch to figure this out really quickly because I know that I've got the center for 1. I've got a radius of root 20. And so if my y value here is 1, remember we're trying to work out k. One option is that I'm at 1 and then I need to minus root 20. We're asked for simplified surd form. So root 20 is equal to root 4 times root 5. We tried to take the square numbers out, which is going to be 2 root 5. Or it's going to be 1 plus root 20. So those are our options. Now that is by far the best way of doing this question. The other way you could do it, and I'm not going to go into detail on this, is that you could try to solve, like set y equal k into here, and then you'll have a quadratic in terms of k, and then you can use the discriminant because you're going to have a double root at that point where the tangent is, and that should give you k. But I wouldn't even go there and try that. This is obviously by far the best method. Get a sketch down, draw the horizontal lines, and then relate it to the center. Okay, next up. Right, I might just copy this whole question, bring it down. So we're told the points S and T lie on the circumference of the circle. M is the midpoint of the chord ST. Given that the length of CM is 2, calculate the length of the chord ST. So a lot going on here. Remember, we've got the center, which was 4, 1. And S and T lie on the circles, so maybe I'll just put it, I don't really know where they are. I'll put it here and here. And then the chord is the line that connects these. M is the midpoint on this chord. And then we're told that this length here, let me do that with a straight line as well, is equal to 2. And we're asked to work out the length of ST. Well, let me also get the radius in, because we know the radius, it's root 20. And I think it's a circle theorem that says basically the radius, yeah, this essentially this will be 90 degrees. Um, I mean that okay, another argument for that actually is that I can connect these up. I'm going to have an isosceles triangle, and then if I draw the line down the middle, I must turn that into two 90-degree triangles. So I don't even need the circle theorem. Um, and what I've got is I'm just going to draw this triangle out. So I've got right angle triangle. I've got M, T, C. This is 2, and this is root 20. And so MT is going to be 20 because I've squared root 20 minus 2 squared rooted, which is going to be root 16, which is 4. And therefore, ST is equal to 2 lots of MT because MT was a midpoint, remember? So it's going to be 8. Okay, so diagram really helpful here. Just some Pythagoras after that, but you've got to realize that this is the sort of thing you need to do. Finally, we're asked to find the coordinates of the point where the circle meets this line, x minus 2y minus 12 equals 0. And there's two options here. We can either use the original form of the circle, or we can use this completed square form that we had before. And life's going to be a little bit easier with this one, just because I don't have as many terms. Let me just check. Is this part 4? Yes, good. So x must equal, right, we can do this using substitution because we've got a quadratic here, we've got a linear equation here. So if I make x the subject, it makes sense to substitute in for x because I don't have any coefficient in front of it. It's going to be 2y plus 12. And then substitute in. So I can replace all these x's by 2y plus 12. Now, I know I'm going to have to expand this back out and everything, so you might argue that it would be better to do the other circle. But I don't know. I think this is 12. Maybe they're comparable. Anyway, let's get on with it. So 2y plus 8 squared plus y minus 1 squared equals 20. So now I'm going to expand this out. 4y squared. I'm going to get 2y times 8, 16y, and then I'm going to do it again. So I'm going to get 32y plus 64. If you're not happy with that, then just let me explain. This is a double bracket. So I've got 4y squared, then I've got 16y from here, and then 64. Then this is going to be y squared minus 2y, for similar reasons, plus 1, and that's going to equal 20. We can expect this to simplify quite a lot. Right, I'm going to bring together my y squared terms. So I'm going to get 5y squared. And then I've got 32y minus 2y. That's going to be plus 30y. Common factor of 5 so far, by the way. And then 65 minus 20 is going to be 45. We've got a quadratic to solve for y. And do not try and solve it like this. Divide through by the common factor. Y squared plus 6y plus 9 is equal to 0. So y plus 3 squared is equal to 0. Y is equal to minus 3. In fact, the line that we've just solved for, like the two equations, that will also be a tangent because you can see that we've just got one root. And then I can substitute back in. It makes sense to substitute back into the simplest one. So x is equal to 2y plus 12. So 2 times minus 3 plus 12, it's going to be 6. And that's it. Let's just have a little look at the question. I didn't actually, to be fair, I didn't read it carefully enough, I think. Find the coordinates. So that kind of implies 2, but then it says of the point. So that kind of implies one place. Now I'm pretty confident that, yeah, this has just got one solution. So basically, coordinates, I would always say it's just a coordinate where line meets circle is 6 minus 3. It is, in this case, a tangent. Okay, I don't think you necessarily have to write all of that, but do write it as a coordinate at the end, just because we were asked for that. If you solve some equations, you can get your like solutions x and y, but here we're actually making, making a geometric statement that is where the circle and the line meet. Okay, well done.